All right, so today what we're going to do is we're going to shift gears a little bit. We've been doing a little algebra working with our patterns, but now we're going to start formalizing the language and formalizing the ideas of algebra. Okay? Because remember, at some point, we're going to actually be using algebra to solve some problems and working and do some problem solving with it. Okay? Good. Algebra's your friend. You bet it is. All right. So here we go. First thing I want you to know is what makes algebra algebra. All right? And the only difference between algebra and arithmetic is the introduction of the letters and symbols that represent numbers. Now, you do this all the time. You just don't know it. What if I asked you, what time is it? What would you say? Yeah, what time is it?
It is 12:07.
12:07, right? So I asked you a question in words, and you gave me back a number, right? Okay? But what if I asked you at the end of the day, what time is it? Are you going to say 12:07? No. The number would have changed, right? And that's the idea of a variable. I asked the same question, didn't I? What time? But you give me a different number depending on when the question was asked or the context of the question. And that's what happens with our variables. That's what variables mean. They're simply letters, okay, that stand for some unknown number. Okay? All right. I don't know why it's got all that on there. Let's clear those strokes. All right, so let's introduce it. So the only difference between arithmetic, which is what we've been doing, right? In arithmetic, you can add, you can subtract, you can multiply, and what? And you can divide with numbers. Right? 7, 9, 12, any number. But what we haven't done, what you don't do in arithmetic, is use letters. And the only difference between algebra and arithmetic is the introduction of those letters, which are called variables. And the reason they're called variables is because their values can vary depending on how they're used. Does that make sense? What time is it? You give me a different time depending on which time I ask the question, right? Okay? And so they're called variables. Well, if you introduce the idea of variables, then what happens is we have more to work with than just numbers, right? And so they start getting specific about specific names. Everything in algebra is made up of what are called terms. And this is critical, guys, so make sure you're writing this down. They're made up of what are called terms. If you don't understand what a term is, or you don't understand the parts of a term, then you're not going to be able to understand algebra. Okay? Because what we're going to do is we're going to spend the rest of the semester putting terms together and taking them apart. So if you don't know all the pieces, then that's going to be a problem. All terms have exactly 4 parts, whether you see them or not. So how many parts are there to a term? 4. And we're going to write down what they are. The first part of every term is something called the sign. And you've had a little introduction to that. I was looking on your Education Perfect. You've seen some signs work before, but we're gonna expand it. You're also going to be able to find on your videos some videos about signs. If you want to go back and review those, I'll post those on your OneNote once I have the right OneNote. I wonder who's getting all those other videos and wondering why they're getting them. So the signs are either positive or negative. So those pluses and minuses in front. For us right now, we're just using the pluses to mean addition, minus to mean subtraction, right? But signs become very important, especially as you move forward, and we'll discuss those as we need them. The second part of every term is something called the coefficient. Coefficient is a math term that you need to know. And the reason is because you're going to see these terms used in your directions. And if you don't understand what the word means, then you're going to have trouble with it later. Okay? All right? Okay. Now, for the coefficient of a term, the coefficient of the term is always the number part. So if you have 3x, for example, the 3 is the coefficient. And what it is a multiplier. And you'll see what I mean when we explore this a little further. These two pieces of a term, the sign and the coefficient, are always taken together in that they have a job to do. And their job is to tell you how many of something that you have. Again, exact parallel in English. If there are 4 cars in the parking lot, 4 is the coefficient. That tells you how many cars you have in the parking lot. Right? So, 2 students, what's the coefficient? 2. Right? So really easy to remember. Just a very different word. The next part of every term is something called its base. And the base is simply the variable. Or variables. You can have more than one letter in an algebraic term. Okay? So it's called the base. So the x, the a, y, b, whatever. And it doesn't matter what letter you use. Right now, when we're just beginning working with algebra, we're going to use letters that make sense. So for example, if I'm measuring dogs, I might use the letter what, do you think? D, right? Okay? As you move forward in algebra, you're going to see that some letters are reserved for specific uses. But for us right now, it doesn't matter. Okay? And the fourth and last part of every term is something called the exponent, which is also known as the index. And another word for it is a power. And you'll hear me using them interchangeably. I use exponent most of the time because that's what we use. But your math books here use index or indices or a power. And all of those things mean exactly the same thing. Okay? So those are the 4 parts of a term. And just like the sign and coefficient go together, the base and exponent go together, and they literally name the term. They tell you what kind of term it is you're dealing with. So for example, you can have an X term, you can have a Y term, you can have a D term, right? Doesn't tell you how many you have, right? Just tells you what it is. Okay, so what I want to do is, I want to just look at a few terms, some examples of some terms, and then I just want you to identify the pieces for me, right? Now, Y, and these are algebraic terms, so say I have negative 4a to the third power. This is an example of an algebraic term. Can anybody tell me why I'm calling it algebraic? What does it have in it?
It's got letters.
It's got a letter in it, you bet. So that's all algebra means. Algebra means that we're using letters to replace numbers that we don't know yet. That's it. How easy is that? Okay? So let's determine the parts of it.
A Google plexine could be A.
So the first part of every term is its what?
Sign.
And that's the plus or minus in front. And in this case, the sign is what? Is the minus, right? Okay, be careful, okay? The second part is called the what?
Coefficient.
The coefficient. And that just means the number part. What is the coefficient here? 4. Okay? So in this case, the sign is the minus. The coefficient is the 4. But those are usually taken together because they name the term. So we would say that the sign and coefficient, or the coefficient is negative 4 or minus 4. But you need to recognize that they're distinct parts. What's the next part? Well, the base, which is the variable, right? And what is the base or variable here? A. And on every base, whether you see one or not, there is an exponent or an index or a power. I don't care which word you use. You make yourself happy. And what is the exponent here? The 3. Okay? And they're all there whether you see them or not. So, look at this one. This is an example of an algebraic term. I know it's algebraic because it has a what in it? Oh, a letter. There you go. A letter in it. Good. So it should have all 4 of the parts. So let's see if it has all 4 parts. Okay, let's get rid of that. First of all, it should have a sign. Does it have a sign?
No, but if it doesn't have a sign, it means it's positive.
Exactly. Excellent. Yes. If you don't see a sign, you always assume a positive. Okay? So it does have a sign. It's a positive. It has to have a coefficient. What's the coefficient in this case?
2.
The 2. Good. It has to have a base, which in this case is the x. Excellent. And it also has to have an exponent.
Is it 1?
Yes. If you don't see an exponent, you always assume an exponent of 1. Okay? So the exponent is 1. So sometimes you're going to have pieces of a term that don't look like they're there, and you assume that they're there. Let's do this one. This is an algebraic term, and it has all 4 parts. Okay? Hold on just 1 minute. Let me erase this just to get you ready. Just like we said last time, if you don't see a sign, you assume that sign to be a what?
Positive.
A positive. Is there a number?
No, it's 1.
Yes. If you don't have a number, you assume it to be a what?
1.
A 1. Excellent. Good. Because it's just like if you had a computer. You wouldn't say this one computer. You'd just say computer, right? So if there's no number, you assume it to be a 1. We do have a base, which is what? A. And what is the exponent if you don't see one? Power of 1. All right? So you see that they're all there. Now, this is a term as well. But is it algebraic? No. Why not?
Because it doesn't have a letter.
Does have a letter.
Because algebra is a letter replaced.
So some letter to replace some unknown number. Exactly. Good. But it is still a term. This is called a constant term. And if you think about it, that makes perfect sense, because can 7 ever equal anything else? No. So therefore, its value is constant. So 3. Can 3 ever be anything else? Nope.
No.
So its value is constant at 3. Make sense? So that's where we get constant terms. And they are terms, so make sure you remember that they are terms. Okay? All right. Excellent. Now, so let's go to, we've talked about terms and we've talked about those ideas. Let's go to Education Perfect and make sure that we get some samples and ideas of what they do. So in algebra, you use letters or symbols to represent numbers. Those letters are unknowns. In order to get an idea of how variables work, they're going to take you on a sailing adventure. I don't know, this might be a little too young for you guys because y'all are so mature and good at this, but, it's a sloth with a telescope. I mean, come on. Can't it? So look, for example, here. They're talking about wind speed, and wind speed is measured in knots. And then they have motor speed, and in this case, the motor speed is also measured in knots. And we know how many knots the motor is. How many knots is a motor going? 10. But we don't know how much the wind is blowing, right? Do you agree with that? Okay. Good. Okay. So they've put a question mark there. I could just say, how hard is the wind blowing? But do you want to write how hard is the wind blowing, or would you rather write X? Right. Yes. So in algebra is all about simplifying, making things as easy as possible. So we could say that the total speed is 10 knots for the motor, plus however fast the wind is blowing us. But again, we don't want to write all of that. Okay? Now, we could simplify it a little more. Our total speed is 10, which is how fast the motor is going, plus the wind speed. That's a little better, right? Wind speed is a little bit easier than writing all of this, right? Okay? There you go. But we can simplify it even more. Okay? Now, we consider the wind speed to be a variable because does the wind always blow the same amount?
No.
You guys are Wellingtonians, you know it, right? Okay. Okay. Sometimes it blows like too much, and sometimes it blows way too much.
And sometimes it blows
Way more too much. Yeah. Okay. Sometimes it's nice. Okay. So let's say for example, one day the wind is completely still. So not Wellington. All right. So we get no extra speed from the wind. In that case, look at it's 10 plus how much wind? 0 wind, so 10 knots. Okay? But what if the wind speed was 20 knots? Then that means that you're going to get 10 plus 20, which is 30 knots, right? So you see you're just adding the wind speed to the engine speed. But sometimes you're not going to know how much wind speed, and we want to represent, but we know that we need to take our 10 plus our wind speed. And so what we can do is we can write an algebraic expression, and I'm about to define that, an algebraic expression to show that pattern. 10 is the motor, always going to go 10, right? Plus wind speed, and just like you were saying earlier, a good way to say wind speed would just be to say what? W. And you know if you add those two together, you're going to get your speed, the speed of the boat. Okay? All right. You don't have to use W, though. You can use any letter you want to. Or you can use a symbol. So they give you all kinds of symbols here. But use one that makes sense. Now, do any of these really make sense for wind? No. So wind would probably be better. Yeah, wind makes more sense. And usually when you're dealing with a specific application like that, that does work. Use one that makes it easy to understand. Okay? So look, for example, what variable would you choose to represent number of bananas, you think?
B.
B. Makes perfect sense. Good. Okay? All right. So then it goes into your homework. I'm not doing that for you.
No.
Instead, I'm going to come back over to the next section, which is an expression is. So let's go back to paper so that I can write out some notes. Now that we know what a variable is, and that it just stands for some unknown number, we need to talk about something called an algebraic expression. Excellent. An algebraic expression simply means any combination of constants. I'm using math words. What does a constant mean? Stays the same, so it's just a number, right? Constant is just another way of saying number, right? Okay? 7 is a constant, and that can't change. So we'll go our example, 10 was our constant speed from the engine, right? Constants, operation symbols, like plus, what? Minus,
Division.
multiply, divide, right? And you know me and my x. Did I already talk about that? All right, we'll use x for now. I don't use x to mean multiply. Can anybody think why?
Because you might think that.
Yeah, I might think it's a variable, right? I don't know x the whatever or x the variable, x the multiplication. So most of the time, what you'll see me write, now the Education Imperfect is still going to use the x for multiplication, but what they do is they use the funny x like this for the variable and the really straight x like that for the multiplication. but you'll see that I can't draw those really well, so I don't like that. Yes?
How I do it is this, so like 2 lines.
So like that.
Yeah.
Okay? Perfectly happy. Do it that way if you want to. I'm fine with it, right? Because that's the way you learned. But you could also write multiplication with a dot. Anytime you see that dot, that indicates multiply. And we're going to talk about even more ways to write multiplication as we move forward. Okay? Now, so combination of constants, operation symbols, and variables. Any combination of those can make up an algebraic expression. But what it can't have, and this needs to be written big because it's really important, you can't have an equal symbol. Because if you add an equal symbol, then you no longer have an expression, you have an equation. And they're totally different animals. Absolutely different rules. Okay? So, can it have a 9? Yep. Could it have a plus? Could it have a B? Could it have an equals? No. All right? So, any combination. So, 7y plus 3x minus 4b times 11 divided by 45z. Who cares? Yes?
Why are there 2 pluses?
That last plus is a division symbol. There's not. It's just me. How's that? Better? Sorry.
I don't have a division symbol on my laptop, so I'm doing a percentage symbol. Yeah, like you can't do the times symbol.
Yeah, so you can do the line, the fraction bar. You can also write division like this. A over B. So write it if you want to type it in. But yeah. Okay. And we'll talk about that a lot too. All right. So let's go back to Education Perfect and see what they have to say about expressions. Okay. So now we got some new sales and we can go twice the amount of wind speed as before. Okay. Did the wind increase? No. What increased? The sails, which means the amount of wind we can harness, right? By how much? Twice means what?
Double.
2 times or double. Yeah, double is another way of saying the same thing. Double or 2 times is twice. Yeah. So instead of just W, what would it be? 2 times W, right? Because the wind didn't increase, but how much wind we can capture did, by twice as much. Okay? So we've got now have 2 times W to represent our wind. Make sense? What if I tripled the amount? What would that mean? 3 times our W. Okay? So again, it's not the wind that's changing, it's how much wind we can capture that's changing. Good. Okay? So now, if our motor goes 10 knots and our wind is 2 times W knots, just add those together and you would get 2 plus W plus 10. Or 2 times W, plus 10. 2 times our wind speed plus 10. Right? So another example of an algebraic expression. Okay? Look at some other expressions you can write. Some number plus 1. Some number. I don't know what number, but it's not dogs or wind or cats or anything. So typically, if we're just saying some unknown number, we usually just use X to represent that. Okay? So to look at this one, some number plus 1, X plus 1. 5 times a number. What number? I don't know. So 5 times some number. And this time they used Y. X and Y are the most commonly used variables, but who cares? What, do you have a favorite letter? N? Boom. S. B.
Xylophone.
Then who cares?
Xylophone.
Use whatever letter you want. Now again, Later, you're going to see that some letters are reserved for certain uses because they're always used to represent the same thing. But for now, we don't care, right? Now, but if they tell you to use X, then what?
Use X.
You better use X, right? Because remember, this is not a person grading this machine. Okay? So, imagine you're still not going fast enough, so you decided to add paddles. So now we have some P's. I don't know if you're being chased by something, yeah? Yeah, it's a sloth. They like, you know how fast the sloths like to go. All right, so now we have P. So if we use P to represent the paddles, then we introduce another variable, but it's just adding to what we already had. So 2 times W plus 10 plus P, right? So remember, we can build these up and have as many variables as we want or need. Okay? All right. We can also have variables occur more than once in the same expression. So look at this one, Guy. So it's 1 plus y minus 2 times y. But what you have to remember is that if a variable is used more than once in the same sentence, then it has to be the same variable, the same number. Exactly, good. So if y equals 3, if y is 3 in one of them, then it has to be what? 3 in the other. Okay? So anytime you do use the same variable in the same sentence, it has to be the same number. Okay? So keep that in mind. It will always be the same. So how about our second group of paddles? Well, then that means you have paddles plus what? And more paddles, right? P plus P. Okay? Now, what if we have 2 different items? Can I use the same letter for 2 different items? No. So here, I'm a dog. Is that true? No, one of those dogs is a cat. So I could say C and D, right? But I couldn't use D for both of them. Make sense? Because you're talking about distinct items. Okay? All right. Now, different numbers, different variables. So if I have 5 plus 5 and I wanted to write that with just one set of letters, could I use the same number for that? Sure, because they're both 5s, yeah? But what if I had 2 plus 3? Could I write that as x plus x? No way, because you can't use the same letters. What could I write?
A plus y.
You betcha. X plus y, A plus B, Z plus D. Who cares? Doesn't really matter what letters you choose, but because they're 2 different numbers, you have to choose 2 different letters, right? Good. Okay. So, we know now that a variable is some unknown letter, and we know that an expression is simply a collection of constants. What's a constant mean?
Stays the same.
Well, so just a number. There you go. So it stays the same. So a number. So constants, variables, and operation symbols. What can an expression not have?
Equal signs.
Equal symbols. Excellent. Excellent. And you can say sign, but in reality, it's an equal symbol. Those are mathematical symbols, but that's okay. All right? So there you go. How's it looking?
Beautiful.
Beautiful? You're so happy? You're ready to do so much algebra that you never want to stop doing algebra? You want every day to be algebra class from now on? And perfect. I love it.